All right, today we're going to discuss the specific conic section of hyperbolas. We're going to talk about the definition, and then we're going to talk about the particular characteristics of a hyperbola. We're going to graph and translate hyperbolas. You're going to be able to find domain and ranges and find equations of hyperbolas. Okay, so first, definition. So locus of points, collection, right? Locus just means collections, such that the difference of the distances from two fixed points, which we call foci, to a point on the collection of points is a constant. What does that look like? Here's a point that's on the locus of point, right? It's on the collection of points. And then this distance minus this distance is going to be constant, okay, for any point that you pick on the hyperbola. Okay, so for hyperbolas that open up horizontally, they come in this general form. If you like to memorize general forms, it's going to look like that. More importantly is the work form, right? The work form looks almost like the equation for an ellipse. The only difference is that there is a subtraction instead of an addition, right? So subtraction, so it's a hyperbola. We do have two asymptotes for hyperbolas, and they're given by the equation plus or minus b over a x minus times x minus h plus k. So this b and this a come from the work form, right? And so do the h and the k. Those are the center, right? Then you have your foci points, where hyperbolas that open up horizontally, you get that from taking your c, what you get from a squared plus b squared equals c squared. So you take your c and you're going to subtract and add it to your h value, and that's how you get your two foci points. There's also something called the transverse axis, and that is where your foci points lie, and that's just going to be y equals k, whatever your k value is for your center. All right, so this is kind of what it looks like when hyperbola is graphed. Here you have your A value. There's a B value. The C value is from the center to one of your foci points. You have here the two foci points. Here's the fundamental rectangle. That's you get your fundamental rectangle from your A and your B value. Your transverse axis is where the foci lie on. You also have something called the conjugate axis, and that is just the perpendicular axis to the transverse axis. So for a vertical hyperbola, it has this general form, so you can recognize it if it's in general form. The difference between the work form of a vertical and a horizontal hyperbola is that your y minus k squared is going to happen first, and then you're going to subtract your x minus h squared over b squared. So again, your y is going to appear first, and that's going to clue you in that it's going to be a vertical hyperbola. The equation of the asymptotes is figured out the same way, though. It's still plus or minus a over b times x minus h plus k, so that doesn't change. Your foci are going to change a little bit. Instead of adding and subtracting c to h, you're going to add and subtract c to k because your foci are going to be vertical from each other. And then also what's going to be different is your transverse axis. It's going to be x equals h because it has to be a vertical line because it's opening vertically. Yes. So this is an example of a graphed vertical hyperbola. So the eccentricity of a hyperbola is always going to be greater than 1. If you calculate an eccentricity of a hyperbola and it's not greater than 1, then either you're not looking at a hyperbola or you calculated your A, B, and C incorrectly. So it should always be greater than 1 when you calculate that eccentricity of hyperbola. So let's practice graphing. The first thing I recognize is that this is a horizontal hyperbola. It's going to open up horizontally. I know that because my x is appearing first. The thing you want to do is find your center, right? So your center is at 1, negative 1. I'm going to go ahead and graph that. Then we want to build our rectangle. In order to build a rectangle, we have to know what our A and our B is. So our A is going to be 2, and our B is going to be 3, right? Because A squared is 4 and B squared is 9. So that means A is 2 and B is 3. So from the center, you're going to go 2 to the right. You're also going to go 2 to the left. And you're going to go 3 up, and you're also going to go 3 down, and it's going to make this nice little rectangle for you. From that rectangle, you're going to draw your asymptotes. Now, you could calculate the equation of the asymptotes, and some problems will ask you to do that. If they don't ask you to actually give the equation of the asymptotes and you just have to draw them, all you need is your fundamental rectangle. You're just going to sketch a diagonal through that rectangle, and those are your asymptotes. Okay? Now we know it opens horizontally, so you're going to use your asymptotes to guide you onto sketching the graph. So the graph is going to go right along those horizontal asymptotes, and it's not going to cross over into your fundamental rectangle. So again, your asymptotes help guide you, and then it's not going to go over into the horizontal rectangle, the fundamental rectangle, fundamental rectangle is not going to cross over into that. Awesome. All right. So here they have a general equation for hyperbola, and they want us to find the A and the B value, which makes sense because the A and B is so useful for many other things, right? So we have to put this hyperbola into work form. So just like, when we did with the ellipse, the first thing we want to do is we want to group our x terms and our y terms together, and then we want to factor out any constant in front of the squared term. So in front of my x squared, I have a 4, so I need to factor out a 4. In front of my y squared, I actually have a -1 since it's minus y squared, so I want to factor out a negative from my y terms. That's how I got negative, parentheses, y squared minus 4y. I factored out a negative. And then I have equals -92. Now I complete the square, and I make up for completing the square on the other side. That's how I got the 100 and the -4. And then I go ahead and write that completed square as perfect squares. And then I'll divide by 4 on both sides, for both terms. And then I have a work form. Okay, from that work form, I can figure out that my A value is 1 and my B value is 2. All right. Now they want us to find the center. Well, since I put it in work form, I can easily identify my center as 5, 2. Now it wants us to find the foci. So the first thing I have to think of, well, this is opening horizontally because my x information is happening first. So this is opening horizontally. So I look back, how do I find the foci for a hyperbola that opens up horizontally? Well, I do h minus c, comma k, and h plus c, comma k. Well, I know what my h is, and I know what my k is, but what's c? Well, remember, we get c from doing a squared plus b squared equals c squared. And I know what a and b are. A is 1 and b is 2, so I can solve for c as the square root of 5, right? So my first foci point is 5 minus the square root of 5, comma 2, and my second foci point is 5 plus square root of 5, comma 2. All right, now we need the equation of the transverse axis. Remember, when it opens horizontally, that is just y equals your k value. And since k is 2, my transverse axis equation will be y equals 2. Now the equations of the asymptotes. Remember, I do plus or minus b over a times x minus h plus k. So I'm going to get 2 different equations. Okay, so plus or minus, and my b is 2, my a is 1, my h is 5, and my k is 2. So I plugged all my values in. And so let's do just the positive first to get our first equation. So I'm going to do positive 2 over 1. Okay, so I distribute the 2, and I simplify, and I get y equals 2x minus 8. Now let's do negative 2 over 1. Distribute my negative 2, and I simplify, and I get negative 2x plus 12 as my second equation of the asymptotes. All right, find the eccentricity. So eccentricity, remember, is c over a. We calculated our c to be square root of 5, and our a is 1, which means our eccentricity is the square root of 5, which is 1 supposed to be. Now it wants to graph. Well, we knew our center was 5, 2, so I'm going to go ahead and plot that. We know our A and our B, so I can make my fundamental rectangle. Remember, A is 1, so I'm going to go 1 to the right and 1 to the left. B is 2, so I'm going to go up 2 and down 2. And that's how I'm going to make my rectangle. I'm going to go ahead and put my 2 foci points on there. Okay. And I'm going to go ahead and graph the lines of my asymptotes. So I could use the equations of the lines that I had figured out, but I also know that if I have a fundamental rectangle, that I can just draw my asymptotes going through the diagonals of that fundamental rectangle. All right, and then using those asymptotes and using the fundamental rectangle, I will go ahead and sketch my graph. All right, your turn. Go ahead and try 6.4, number 2 through 6 evens.